Okay, we did the long division and obtained this result shown here. We still have a rational function as the last term. Do we need? Let's look at the degree of the top polynomial and the bottom polynomial here. The degree of the top polynomial is 0 since there is no x term there. The bottom polynomial has degree 2, so this is okay. We don't need any more long divisions. But what do we do with this last term? We need to factor the bottom polynomial. So let's factor the bottom polynomial. I have 1 over x squared minus x minus 6, and by observation I can determine that it's x minus 3 times x plus 2. Okay. So this is a rational function that I need to decompose into two fractions, and that's the reason why we call this partial fractions. So let's and these are called linear factors. X minus 3 and x plus 2 are two linear factors, and we will also deal with examples where I have repeated linear factors and also a quadratic term that cannot be factored. Those examples we'll handle in the next videos, but in this we'll just deal with how to decompose this particular rational function with just the linear factors. So I could write 1 over x minus 3 times x plus 2 as a over x minus 3 plus b over x plus 2, where a and b are just numbers and we need to find out what the values are of those two numbers. Right. And the way to do that is basically solve this big equation here. And one way to solve this is multiply both sides of this equation by what's in the denominator here, x minus 3 times x plus 2. That would give you 1 equals x minus 3 term would cancel out, and I would just have x plus 2 at the top plus b times x minus 3, and that would be 1 equals ax plus 2a plus bx minus 3b. Okay, so I can write this as x times a plus b plus I can group the remaining numeric terms, 2a minus 3b. Okay, so how do we solve this? Well, if you look on the left hand side, there is no x term. Therefore a plus b must be equal to 0. Since there is no x term on the left hand side, a plus b must be 0. And also there is the numeric term on the left hand side is 1, and this is supposed to be the numeric term 2a minus 3b. Therefore 2a minus 3b is equal to 1. Well, this would the top equation here can be used to write a equals negative b, and if you substitute here, you'll get negative 2b minus 3b equals 1, and that's negative 5b equals 1, and that basically gives you b equals negative 1/5. Therefore, a must be equal to 1/5. So we can write this rational function as 1/5 over x minus 3 plus negative 1/5 over x plus 2. So let's put it all together. We had this rational function to start with. We did the long division and we obtained this result. And in the next step, we took this rational function term at the end here, and we factored the bottom polynomial. We got this, and we decomposed this into two terms, two simple linear factors. Okay, so putting it all together, we would see that this rational function is equal to 3x plus 1. That's the first two terms here, minus this, but we found out this was this thing here, so be careful to multiply these terms here with minus. So minus this term will give you minus 1/5 over x minus 3, minus times minus 1/5 over x plus 2 will give you plus 1/5 over x plus 2. So this is what we have. So this completes the decomposition into linear fractions. Okay, decomposition into partial fractions rather. So suppose we were asked to integrate this expression. Let me write it. Suppose we were asked to integrate this function with respect to x. We would have done everything we did in so far in doing the long division, decomposing the remaining rational function into partial fractions, and we would end up with this. And this is fairly easy to integrate. So let's integrate each term here. We have 4 terms, 3x, 1, this term here and this term here. Okay, integrating the first term, 3x dx, would give you 3 times x squared over 2. Integrating the next term, 1 times dx, that would give us x. And to integrate this term here, that would be 1/5 ln absolute value of x minus 3, and the last term would be plus 1/5 ln of absolute value of x plus 2, and of course there would be a constant of integration too. We can write plus c. Okay. We can simplify this a little bit. So this would become 3/2 x squared plus x. I can actually say 1/5 ln x plus 2 over x minus 3 plus c. Remember, integral dx over x is equal to log natural log of absolute value of x.